Okay, now we're recording. Please do not call me that. Yes. Yes, pencils, come up. Anything that's up here, free to use. It's just one of the things one of my pet peeves. Does that make sense?
Yeah.
Okay. Not mad at you. You don't know.
Yeah.
Just one of those things. Okay. So I am going way back. I'm going back to stuff that you guys really need to know. And I'm being a little heavy-handed here in the beginning. We'll not always be as heavy-handed as we progress throughout the year. But there's a few things I want to emphasize. And it's because these are rules that follow through algebra, algebra 2. Every class you have, these are the same rules that you have. Okay, the keys to solving equations are two things to solving any equation. Okay. Number one, do the opposite. And my handwriting is horrible, and for some reason, this is off. Reset. So step number one, do the opposite. If you're trying to solve addition, do subtraction. If you're trying to solve multiplication, you do division. Okay? Always do the opposite. When you're solving equations, your first step is to do the opposite. Yes, my handwriting is crap. I freely admit it. You must listen to me when I'm saying it as well as writing it down. That's why part of the reason why paying attention is important, because my handwriting is crap. And if you listen to me, oh, that's what he said, do the opposite. You tend to remember that a little bit better. Okay, so your first step is to do the opposite. Like I said, if you're trying to solve a multiplication problem, you divide both sides. Okay, if you're trying to solve subtraction, you do addition. You do the opposite. Generally speaking, it also works with solving. You also want to do the opposite of the order of operations. Last thing, generally speaking, it's not always true, but generally speaking, last thing you do with order of operations is add and subtract. First thing you do when you're solving is do the add and subtract. Generally speaking, but not always. But that's a good rule of thumb when you're solving a basic equation. Second rule, and this is actually the more important rule, do the same thing to both sides of the equal sign. Do the same thing to both sides of equal sign. I almost spelled that wrong. And my spelling's atrocious too. But I'm a math teacher, not an English teacher, so it's not too bad. Okay. Do the same thing to both sides of the equal sign. And this is probably the more important rule, because eventually when you're solving equations, you have other things that you're doing other than just doing the opposite. My calculus students, when they do their calculus part of their work, because they may have a problem that takes them 5 or 6 steps to solve or even more, generally only one of the steps is actually doing calculus. The rest of it's all algebra. They're really, really, really good at algebra by the time they get done with that class, because they do a lot of algebra in there as part of solving their calculus problems. But when they do their calculus work, they do the same thing to both sides of the equation. You absolutely must do to both sides. You can do anything you want in solving as long as whatever you do to one side of the equal sign, you do to the other side of the equal sign. If it's a fair move, if it's good math and something you mathematically do it. Just do it to both sides of the equal sign, because if you don't do it to both sides of the equal sign, you're no longer in balance. You're no longer equal. If you add to one side, you better add to the other side, or you're no longer in balance. That's the key. You can do almost anything you want, as long as whatever you do to one side of the equal, you do to the other side. Even if it's not something that's gonna get you the right answer right away, eventually it'll all work out because you did it to both sides. As long as it's a fair move, do it to both sides, you're okay. You're not going to screw things up beyond repair. You may make things a little harder on yourself by doing extra work, but you're not going to screw it up. Okay? You're not going to screw it up as long as you do it to both sides. Now, I am a stickler for working vertically rather than horizontally. Okay? Anytime you solve a problem, you work vertically. You work down. You don't work across. I saw something the other day that just drove me nuts. Absolutely drove me nuts. So, we're not going to do this every time, but you will see on most of the pages that you have left on this in the packet, you will see where you have solving equations, and these are example pages, and it'll have what you do and your explanation. Not every single time, but often, particularly in the beginning, I'm going to have you write down in words what you're doing mathematically as well. It's probably going to be the one thing that's going to slow us down more than anything else in here. I have my reasons. Trying to reinforce what we're doing in here, trying to get you to be good math students, trying to get you to have it be second nature. Okay? Because when this stuff becomes second nature to you, other stuff becomes easier. Okay? I have my reasons. I never do anything as instruction without a sound reason for what you need later. I don't do anything to be mean. I don't do anything to just keep you busy. If I give you something, if I have you do something, I've got a reason behind it. And it's to make you better. Okay? It's to give you success later on. Okay? So, solving one-step equations. This is basically most of every type of one-step equations we're going to be dealing with. So the first one, x plus 5 equals 8. What is this? No, I didn't ask the answer. What are we doing here? Addition. How do we solve it? By doing the what? Opposite. So what do? Subtract what? Subtract 5 from both sides of the equal sign. So our explanation was subtract 5. I want you to write down in words what you're doing mathematically. What am I doing? I'm subtracting 5. And then do it. The x comes down. The plus 5 and minus 5 cancel, equals 8 minus 5, 3. X equals 3. I have my reasons. Okay? I want this ingrained in your head. I want this to be second nature. Okay? When you play sports, why do you practice? Muscle memory. Why do you shoot free throw after free throw after free throw? If you're on the basketball team, why do you practice shooting free throws all the time? Muscle memory. Practice. That's why. Okay? That's why you do it. Same thing here. Muscle memory. I know your brain's not a muscle. I'm not that stupid. Okay? But it's the same idea. You do things over and over again, it becomes second nature to you. And math is one of those things. You use parts of your brain in math that you don't use for anything else. Math is great calisthenics for your brain. It really is. It's great calisthenics for your brain. Okay? People who do math, are good at math, generally are considered smarter. Generally. But that's because you use parts of your brains when you're doing math you don't use when you're doing other stuff. You use more of your brain when you're doing math. I'm trying to incorporate as much as possible in this. Okay? So the next one, y minus 7 equals 2. What's this operation we're doing to y? It's subtraction. So what do we do to solve it? Add 7 to both sides. Add 7. So what did we do? We add 7 to both sides. I do want you to, like, we're not going to be doing that forever, but I am going to ask you to do that for a while here in the beginning in particular. Okay? And then do the work. Get y equals 9. And like I said, I really hope you can solve these problems without having to do this work. I really hope you can see the solutions. Does that make sense? But doing the work is an important step. It is an important step. It is an important thing to do. Okay, next one. What's being done here? What is 5p?
5 is being multiplied by p.
Yeah. When we slap two things together that are different like that, it's multiplication. Okay, if I have a variable and a number slapped together, it's multiplication. There are people that forget that, but yeah, it's multiplication. What's the opposite of multiplication? Division. So we're going to divide both sides by 5. Divide by 5. Dividing by 5. This is an important thing, what we're doing here. Our process is dividing by something. Okay? 5p divided by 5. I know I like this, they cancel. P equals negative 15 divided by 5 is? Negative 3. If you can get your negatives and positives, that goes a long way towards your success. If you struggle with negatives and positives, I'll be happy to help you work with you on that. Okay. What is this right here? Division. K divided by 11. So what am I going to do to both sides? Multiply both sides by 11. Times 11 times 11. I am multiplying by 11. Now I like these because they just cancel out. And I get K equals 66. Easy peasy. Okay, does that make sense? Like I said, we're going to start out easy here. We'll step it up as we go along. I want to see where you're at, and I do have my reasons. Okay. Your turn. When I come up on a page like this where it says your turn on the top, guess what that means? It's your turn. You do them and do exactly what we just got done doing. Do the work, show the work, write the explanation. So let's do these. We're running a little short. We're going to run out of time. I want to get this done before the period ends. Right? Let's see. Yeah. We actually got like 2 minutes. So the first one, what do I do here? What do I do?
Subtract 5.
Subtract 5 from both sides. U equals negative 9. Subtract 5. Okay, what do I do on this one? And this is an important one. Divide by negative 3. Okay, hang on. Class is not yet over. I do like to give you a little couple of minutes at the end to pack up, but I want to get this real quick. Okay, this is an important one. I had a question. What is 5 divided by 3? Okay, here's what I want to see. No, because it's a negative divided by a negative. It should be positive. Okay. We'll get these last two when we come back, but this is important. Please pay attention. I know you want to leave. You can't wait to get out of here. I understand that. Improper fractions reduced. You only give me an answer in another form when that answer is more appropriate. I would not say 5/3 of a pizza. I would say 2 2/3 pizzas. A mixed number makes sense when I'm talking about an amount of an object, right? It might need decimals if I'm like talking about money. I don't want to talk about 5/3 of a dollar. I want $1.33, right? But if you're not doing that and you're strictly solving an equation, leave it improper. Always reduce, but leave it improper. Okay? That's my standard. That's what all my answers are in. Now, if you give me something else, it doesn't mean I won't mark you wrong, because I can figure out that, yes, this is 1 2/3, but I want 5/3, not 1 2/3. Okay? Does that make sense? Awesome. We will finish this up.